All right, so for this one, I need to get myself a little bit smaller. Okay, let's get my life into this corner. All right. Yeah, I'm still here, but I'm just in that corner. And probably should start on the left side. So let me just go move over. I hop over again, over to the other side. Okay, here I am. Yep, sorry about that. A little bit silliness is good from time to time. Just look above me. So to be a little bit more realistic is you actually have a limited horizontal extent of ocean basins. So instead of having purely zonal flows in the ocean, geostrophic flows, you actually create something that we call gyres, which are large circular movement patterns of horizontal currents, okay, and which are shown here. They run around the high pressure that you get, okay, and sort of clockwise in the northern hemisphere, anti-clockwise in the southern hemisphere. Okay. Now something in addition comes to that. Okay. And for that I have to just run over to the right side. Sorry, it was very fast, but I'm here. It's something that we call westward intensification. And on the real Earth, we actually get not symmetrical gyres. Okay. We actually get stronger currents on the western side of these gyres. It's called westward intensification. And that's sort of illustrated here. It goes back to Henry Stommel from 1948, a paper published at that time. And Henry Stommel explains that no matter where you are in the oceans, you have the gyres in different parts, you always get swift currents near the western boundary of an ocean basin. Okay. And the reason why you get these currents is that the Coriolis force is not the same, or the Coriolis parameter, to be more precise, is not the same everywhere. Okay, so it's negative in the southern hemisphere, it is positive in the northern hemisphere, and it changes. So it increases from the from the South Pole to the North Pole, and this is what we call the beta effect. And it's the beta effect that actually creates very, very strong flows, swift flows near the western boundaries. And these currents are called western boundary currents. And the typical speeds are something between 1 and 2 meters per second. Western boundary currents. Okay, very important features in the ocean.